Finding the joint perpendicular vector, we have one method, and the method I showed you before, it has very significant advantage over the one I'm going to show you right now. Here's the advantage. Cross product lives only in 3 dimensions. We don't have any analogy of cross product in higher dimensions. However, in 3 dimensions, it's a powerful computational method which is quicker than the general method we discussed with you last time. So here's how you do this on the computational side. Cross product, normally you write a symbol like this. So you will see lots of symbols right now on this slide. You'll see lots of symbols on this slide. Many of them you should take as it is, without thinking much what's the underlying reasons why we use these symbols. It's just a way to remember things better. Later on, in 2 weeks' time, you will probably I'll give you more sense to this. Right now, we just remember this as they are. So normally the cross product computationally, it is written like this. It's a table of symbols, 3 by 3, where first line is filled with the vectors I, j, k. I hope you remember the vectors I, j, k. That's the 3 basis vectors of my 3-dimensional space. And the other two lines is just you filled with the components of your vector A and your vector B. That's how you start computing the dot product. For those people who are curious, this piece is called the determinant. If you're wondering, you can read the articles on Wikipedia about that, but it's totally just, we're not relying on that information. For us, it's just a nice way to write the components involved in the cross product. Just to remember, first line, you put the vectors I, j, k. Second line, you put the components of the first vector. Third line, you put the components of the second vector. Now, why do you put it this way? Because it's easy to remember what you're going to write next. And what you're going to write next is this. You're going to write the vector I, and next to it, you're going to write the table, 2 times 2 table with these entries. Here it is. Now, next you're going to write vector j. Imagine you just cross out this piece. It's no longer here. And then you will have a table consisting of this piece and this little column. Again, 2 times 2. Here it is. A1, B1, A3, B3. And finally, you take the k vector. Imagine you just forgot about the existence of this column, and then the remaining 2 will be these 2. Now, finally, computational stage starts right now, because each of these little tables, we're going to replace them with the one number. Each of these little tables, they are also called determinants. This time it's determinant of size 2 rather than 3. Each of these little tables, they will be replaced with a number, and that's how we compute this number. For our purposes, we need a quick method of finding a joint perpendicular vector, and that's a quick method. It is a quick method, trust me. It is quicker if you check the solutions I presented last time. This is a quicker method. That's the reason I brought this up right now. For now, the pathway is clear. You just build something like this. That will be the first component of your vector. That will be the second component of your vector. That will be the third component of your vector. And each of them, that's the way we compute them. It's a lengthy computation. It seems like a lengthy computation. The reason I brought this, the other reason we write this like this, is just it's easier to remember this way. If I just simply replace every square table with the expression like this, in here, and in here, I don't know if that would make you happier. On one hand, of course, you won't be facing any new strange symbols, strange tables. Everything will be very clear. Number times number, take number times number, take another numbers, take number. But on the other hand, I don't think you will ever be able to remember that, even though you will be very happy. Right? So the reason for even if I won't give you any explanations, there is still a very powerful reason for you remembering this table, for using these tables. It gives you a nice way to remember things. Just do this exercise. Try to replace each table here with the expression like this. So here will be A1 times B3 minus B1 times A3. Here will be A1 times B2 minus B1 times A2. Replace it. Look at this for 5 minutes, close it, try to write this down in half an hour without help of your notes. I don't think anyone will succeed in this class. However, if you look at this for 5 minutes, and if you remember this strategy, how we unravel down to this, in half an hour, half of the class will be able to reconstruct that. Maybe the whole class.